let's start trying to figure out how we'll find the closest fire. The first thing we're going to do is take that JSON data and parse it. So we'll store it in a variable. We'll say fire data. And to parse it, we'll just use JSON parse, which basically splits it up. And we're going to take our response and the body of the response. So now we've got our JSON data, and we can start iterating through. So let's do a for loop, and then we'll look in fire data dot features. Now, if you remember when we looked at that data, the main part was called features. Let's see if I still have it downloaded here. Nope. Okay, let me go grab it, and then we can start parsing through, just looking at it in Notepad or something. Okay, so here it is, and let's replace the open brackets with an open bracket and a new line. There we go. So first we have this information, then we start with the features, right? And then there's some information there about the different incidents, and then you see the repetition. So there's a feature, feature, feature. So each one of these is an incident, and you can see some of the different information that's tracked for each fire. And they had this on that website as well. You can see stuff like where did I just see that? Fire discovery date, discovery acres, daily acres is the current number of acres burned. There should be a percent contained somewhere in here. Oh, incident name. Here we have some initial longitude and initial latitude. Let's try and find current latitude and longitude. It should be somewhere in here. Okay, that's right here. So you'll see the geometry, it's a point, and here are the coordinates. So you'll have your latitude and longitude right here. So it's going to be within features, and then it's kind of broken out in this way. So you have type, its feature, then the properties, and it has, looks like it's got all this information in the properties, and then geometry, and then coordinates, and then you have that. So let's get some of this information in here. So as we go through for each fire, some of the things we're going to want to know are, let's say, the acres. Let's see the latitude, longitude, percent contained. There were a couple other things as well. There's one feature, is valid, that I had noticed before. Let's see. There it is valid. So we should check that. There's also one fire behavior. So fire behavior null. Let's see with some of those others. Fire behavior general. Null. Moderate, null, active. Okay, so we probably don't want the ones that are null. Let's just take, let me go back to the beginning and then find the first one. So this one's active, this one's null. So let's look at this one, see if this would be something that we would want to display. Daily acres 20.3. And where's our is valid? Is valid is 1, so maybe we do want to capture these as well. So we just want to decide which ones we want to include in our list or not. Okay. But we wanted the is valid. Okay. So let's say var acres equals, and then we'll do fire data dot features, and we're stepping through, so we're going to use the I element, right? And this for loop will slowly go counting up. Dot properties, and then acres be daily acres. That's how it's spelled, and you want to make sure that that's exactly how it's listed in the file. And we can copy and paste this, and so percent contained. Instead of daily acres here, we have percent contained. For our is valid, it's going to just be valid. And our latitude and longitude, those were part of a different subportion. Whoops. So let's just call it lat. And instead of daily acres, actually instead of properties, right, it's geometry and then coordinates. And there were two different ones, so the latitude is actually the second one, and then longitude is the first. So we'll use 0, the 0 item in the array. So this is all of this information. Now we're looping through. Let's only look at ones that are valid, right? So if is valid equals 1. And then also let's look at ones that aren't contained, right? So and percent contained is not equal to 100. No, we don't need to put this on a separate line. It's pretty short. Okay, so we're looking for ones that are valid and that aren't contained. And now what we have to do is find the one that is the closest to us. And we've got latitude and longitude to work with. So what we actually need to do is figure out where we are. We have the zip code, but we need to convert the zip code to a latitude and longitude. So let's do that actually before we get into anything here. So up above here, what we need to do is convert our zip code to a latitude and longitude. Okay, so we'll have to figure out how to do that, and that'll be somewhat similar to how we went and got the fire data. We'll find some way to convert this, or you could get every single zip code in the United States, list it all out, and go through a statement to look it up and convert it, or find a website that'll do that for you. So that's the option that we'll take, because if things change, then we don't have to go update anything. Like, I don't know how often new zip codes get created in the US. So then once we're here, let's add a little comment here. So let's only check for valid fires that are not fully contained. Okay. Now what we have to do is find, let's find the closest one. So to do that, we're going to need to convert 2 different latitude and longitude points into a distance. Okay, and then we're going to need to find the smallest distance and remember which fire incident that was. Okay, hope that makes sense. So let's split this up, and one of the first things we got to do here is convert our zip code to a latitude longitude. Okay, let's switch over to a web browser and let's search for zip code to actually have it right here, latitude and longitude. Okay, this first result here, let's go looking through. Okay, this looks like zip codes, and then we've got the latitude longitude here. So you can just take something like this and copy the data, put it in there, or we could try to use this API. Right, so here would be, we probably don't need this kind of stuff, right? We're just looking for the bare minimum. We put in a zip code, and then we get back, let's try 95762, right? So we've put in 95762, and then we get back the geo point here, the latitude and longitude. So that is perfect. That's what we want to do. So I've already got the code split up, so I'll just go and paste it in here. Grab it, paste it. Okay, so we've got our zip code URL, which you can find through here, right there, and that's where you'll pass in the zip code, so it'll show you how to do it. And then we'll call again, get HTTP, passing our zip URL in, and we'll get our response. And here, the same as before, if our status code is not 200, we'll do an error. Then we'll try to get, we'll reply to the user exactly what the error was. Otherwise, we'll look through our zip data, go through the 0 record, geometry, and coordinates, and get the latitude and longitude. Now, these are only declared here, so we're going to need to declare them as variables up above. So let's go up and let's add bar latitude, and let's -1, longitude equals -1. And then they'll get replaced down here. Okay, so now we've got our latitude and longitude. So now what we need to do is convert that to a distance between two different latitude longitude points. So we're going to want to use a function for that as well. So function get distance, and so we'll do like latitude 1, longitude 1, latitude 2, longitude 2. And this is actually very tricky. If we go back to our web browser, you can do a search, convert to latitude, longitude points to a distance. Right, so you can see here on this sphere, you're trying to calculate basically an arc along the surface of a sphere, which is the Earth. So there's other people that have done all this calculation, so we don't need to redo it. But it's not the easiest. There's a lot of complex geometry going on here, as you can see. Somebody's already gone through and done all this math right here. What we can do is just try and take a snapshot of it. So probably, let's look at C, well, actually C++ might be some of the closest. We might have to redo some of this stuff. But you look at how it's done here, and then you try to implement it in our JavaScript, so, or node.js. So I've actually already done that, so I'll copy and paste it in. Right here. Let me make sure I named everything the same. Okay, so we have our radius of the Earth in miles. We have our first angle. This is the angle, I believe, off the equator. Then, well, I'm not going to bother pretending to explain the rest of this. You do your crazy math complications, and then at the end, you're left with a distance in miles, and then we'll return that. So anytime we call this passing into latitude and longitudes, we'll get a distance in miles. So what we're going to want to do here is, let's say var my distance is get distance, and so let's pass it. So latitude 1 is our latitude, and longitude 1 is our longitude, and then our second point will be the latitude and longitude of the fire. So that's lat and lon, and that is our distance. Now, what we're going to want to do is keep track of the closest one. So again, we're going to want to use some variables. So let's say closest distance, and let's say it's -1. And then while we're at it, closest fire equals -1. And we're going to want to track which one of these it was. Right, so now when do we set that? So if, first of all, if our closest distance is -1, then that's already, we know that this is our first one, right? So if our closest fire is equal to -1, then we know we've got it, right? So our closest fire is, and our closest dist is I, and then our closest distance equals my distance, right? So we'll right off the bat do that. The other way is if my distance is less than closest distance. Okay, so now we don't need to keep this comment, it's redundant. If our distance is less than the one that we previously had stored as the closest, we'll overwrite it and get a new closest distance. And that is pretty much it. So after this, we've captured our closest fire. So we should be done with this loop. And now we can start building our response.